Okay. So let's continue from where we left off last class. Electric field due to an infinite sheet of charge.
तो क्लास से बाहर निकल गए हम लोग get up in the classroom.
Okay. So to find this is third. So draw an infinite sheet of charge. Is extending in all directions. Actually, I need to make it like a 3D diagram.
आपने जानबूझ के ऐसा सोना है या अपना हाथ में ऐसे ऐसा?
No, जानबूझ के सोना है to show that it's not having a finite size. It's extending in all directions. I'm not just to remind you, it's being recorded. Okay, so please restrict your questions to sensible questions. So this is, let us say, uniformly charged infinite sheet of charge. So positively charged sheet, you can imagine, is extending in all directions. Okay. Now, and let us say, now when we had an infinite line of charge, we used the concept of linear charge density, lambda. Now we have surface of charge, so we'll use surface charge density sigma. So let sigma equal to surface charge density so it will be in units of coulombs per meter square. Linear charge density was coulombs per meter, this is coulomb per meter square. So now we need to again use Gauss Law and symmetry principles to solve the electric field due to this sheet. So what Gaussian surface can you imagine which will be symmetric to this sheet of charge? Remember, it's not having a rectangular shape or anything. It's extending in all directions in 2D. So again what we'll do is
मेरी पॉइंट ऑफ रेफरेंस पे बताओ.
We'll draw. Again, I'm drawing a 3D diagram, okay? This edge is towards me, right? Learn how to draw 3D diagram like this. This edge is towards me, this edge is away from me. See here.
So what is the point?
Look here. Look here. Okay? This edge is towards me. That edge is away from there. Actually, like this I am able to see. So I am able to see the further edge like this, closer edge like this. Now in that case, in this end I can see only the closer edge, further edge is behind the cylinder. So I am showing it as a dotted line. Whereas in the front end I can see the further as well as closer end, so it is in solid line. So how to draw a 3D diagram so that it looks correct. And this part is hidden behind the sheet, so you can't see it. That's why these are dotted lines. Understood?
Yes.
So this is my Gaussian surface. And this distance is equal to R. That means each of these areas, let me call it A. So if you think of this cylinder and imagine that it has two caps on the end, circular caps. The end caps have an area of capital A, and the end caps are at a distance of small r from the sheet. both ends.
What the center?
The end caps are at a distance of smaller from the sheet.
On the center.
Yeah, sheet is infinite sheet, infinite. In all directions, infinite.
Oh.
So the every point is a center only. Okay? So this is the situation. So this Gaussian surface encloses a finite amount of charge, which is equal to, Konrad will tell us the charge which is enclosed. How much charge is enclosed in this red area, which is inside the cylinder, Gaussian cylinder. Charge per unit area is
C by M square.
charge per unit area of sheet is sigma. So how much area is this red area?
Pi C.
If the end cap is having area capital A and this cylinder is cutting the sheet, how much area will this red area be?
Pi square H by 2.
Wait. Others be called. No, I asked one boy, let him answer. Imagine this is a uniform cylinder. Imagine this is a cylinder of same area everywhere, area of cross section. This area is A. If I dip it in ink and then put that stamp on this wall, that circular spot will be having what area? A. So if this area is A, how much will this red area be? A. That's what I wanted. So this is also A. If this area is A and charge per unit area is sigma, how much charge will be in this area?
Sigma by A.
Sigma?
सिग्मा ए
Sigma A. Got it?
तो आप मुझे जैसे बोलते तो क्या कंफ्यूजन हो जाता है आप ऐसे
I am asking it in step by step to reduce confusion. You are saying it's confusing. How is it possible? So the charge is
सिग्मा ए
sigma A. So where do we write it? Okay, so we'll say Q enclosed is equal to sigma A. Understood? Okay, so now let us apply Gauss. Okay, now we will apply symmetry principle. By symmetry, we will use it to guess the direction of electric field. So electric field, now the main point about Gaussian surface is the point of interest should lie on the Gaussian surface. So I want to find electric field on either side of the sheet of charge. So let us say I want to find electric field at this point P. So this is the point of interest. So my Gaussian surface lies on that point of interest. So at any point in front of the sheet, what will be the direction of electric field? Nikunj? Away from the sheet? Because it's an infinite sheet, it cannot have any vertical components left over. They will cancel out because there will be equal charge above as well as below, left as well as right. So the only way left is the component which is perpendicular to the sheet. So electric field would be in this direction. Any point P I take, electric field will be away from the sheet. Similarly on this side also, electric field will be
This
away from the
cylinder is
sheet.
perpendicular, right?
Yes,
No sheet.
the cylinder is perpendicular to the sheet. And the unit vector, if I take an area element dA, which is very small, over which electric field doesn't have any chance to change, then this dA vector will also be parallel to the electric field vector. Small area element, the area vector will be parallel to the electric field vector at the end caps.
So what
on the
curved
surface, on the curved surface, if I take some area,
so ये कैंसिल अब नहीं करेंगे
again you are making the classic mistake. If a bottle is kept here, another bottle is kept here, if I push it with 5 Newton this side, 5 Newton that side, will they cancel each other out? Those two forces are acting on different bottles. How can they cancel out?
और पहचान को दो डिफरेंट बॉडीज है
This electric field is acting at this point, this electric field is acting at this point. Okay, now if you take any area element on the curved surface, the area element will be perpendicular, it will be radially outwards from the curved surface, but electric field will be in which direction? Yeah. Look at the 3D diagram. Huh? If anything is missed out and if you need, I will take it separately, not to worry. Okay, good. Thank you for being so alert. Now it's working, right?
very खुशी में preschool.
So far so good.
Okay. So plus the integral of the curved surface E dot dA. Okay? And we know that this is supposed to be 0 because theta equals 90 degrees. And for these two it will become EDA plus EDA. Integral. Agreed? Because theta equals 0 degrees. So if theta is 0 degrees, E dot dA will become EDA cos theta. Cos 0 is 1, so it will become integral EDA. And we know that E is constant over that surface because the point P, anywhere if you take on the surface, it is same distance from the sheet. So the magnitude of electric field is constant over the end caps. Do you get this point?
सब में तो आप same logic लगा लेते हैं.
Yeah.
बस area का मौका है.
Yeah, exactly. So it become
आज तीनों में बहुत similar है.
exactly. So 2 times. So if I add these two, it will become 2 times E integral dA. We'll say electric field is constant over surface which is equidistant from sheet. Okay. So now area is what? A, capital A. So 2EA, and that is supposed to be equal to Q. Q is what? Sigma A. Q is sigma A. So you get sigma A by epsilon naught is equal to 2EA. Till here everyone is with me? Kolar? Till this step is clear? Sigma by Q enclosed by epsilon naught. Q enclosed is sigma A. So sigma A by epsilon naught is equal to 2EA. Integral of all these small ds over the end cap is A. Like this you have 2 times. So that's why the 2. Clear?
वो add जो मतलब ये लिखा है is equal to 0 degrees.
Yeah.
EDA
This EDA is over this surface, end surface. This EDA, दोनों पे 1 ही लिखा. This EDA is over this surface. Both are identical surfaces only, no, of same area. So integral of EDA will become E into integral of dA, it will become E into A. So EA plus EA is 2EA. Clear? So now A will cancel out. So electric field is equal to sigma by 2 epsilon naught. And the direction will be away from the sheet.
So
Away from sheet. 1 minute. For positive charge towards sheet. For negative charge. Okay, this is the magnitude. Direction is perpendicular to the sheet, away from the sheet for positive sheet, perpendicular towards the sheet for negative charge.
R क्या होगा ना? R क्या for positive and minus R क्या for negative?
Yeah. Yes.
So while of theta 90 degree.
See, for a curved surface, did you see here? If this is the cylinder, the curved surface, the area vector is perpendicular to the surface like this. But the electric field is directed away from the sheet. So it's 90 degrees. Yeah? Yes. But
यहाँ पे सब आएगी तो consider 2 points.
this is one end cap. Gauss Law is applied over a closed surface. So all these surfaces which are closing the cylinder, you have to do the integration.
So when you talking about the parallel line of charge, second point, probably we only considered one point.
Which infinite line of charge? No, we consider two. In infinite line of charge also we consider two. Over both the end caps, the electric field, the flux was zero for infinite line of charge. For infinite line of charge, this Gaussian surface was like this. So electric field over this surface and this surface was zero.
So dA
The flux, because electric field is in this direction. dA is in this direction. Here dA is in this direction, electric field is in this direction. So flux is zero here and here. So we only did the total flux over the curved surface. Clear?
So
What?
आपने last step क्या लिखा है?
So last step is electric field is sigma by 2 epsilon naught. That's it.
Away from the sheet.
So direction, this is the magnitude. Direction is, by symmetry we figured out the direction. It is away from the sheet.
Yeah.
That's what I have written. Away from sheet for positive charge, towards the sheet for negative charge.
Towards sheet will be if the
Sheet is negatively charged.
negatively charged.
Yes. Here, now one amazing thing did you notice?
What?
The electric field due to an infinite sheet of charge is independent of the distance from the sheet. Did you notice that?
Yes.
No matter how far you go,
What?
the electric field due to an infinite sheet of charge is independent of the distance from the sheet. So if this wall is a sheet of charge, whether I am here or I am 10 kilometers away, electric field is same. It doesn't get stronger if you go towards the sheet.
Obviously infinite sheet.
For an infinite sheet.
Obviously बात नहीं
नहीं.
It's not so obvious here. You would have thought that the closer you come to the sheet.
वो जितना ज़्यादा चार्ज अप्लाई करना चाहते हैं वो कर सकते हैं.
No value set.
No, the thing is if you go too close, the influence is due to the charges close to you only. The sheet charges which are far away at the edge of the sheet and all, they are too far away from it. So they cannot exert much electric field in the outward direction. Whereas if you go further away from the sheet,
So
more and more charge from the further regions can exert a component towards you. You getting it?
अच्छा हाँ component for also.
So it's the component which is perpendicular to the surface which is adding up. So whether you come closer or further away, they will add up in such a way that you get the same electric field which is sigma by 2 epsilon naught. It's not so obvious. You need to appreciate this result. Now in real life scenario, if you have a finite sheet, how will you apply this? If you have a finite sheet like this formula is applicable if you take a point which is very close to it. So that the distance r is negligible compared to the dimension of the sheet.
For a finite.
For a finite sheet, if you want to apply this result, the distance r should be negligible compared to the size of the sheet. Then it will work.
With the R.
If for example r is 1 nanometer, just exaggerating, and the sheet is 1 meter square, this formula you can apply. I'm just exaggerating. Nanometer is obviously too small. So 1 millimeter you can take. If r is 1 millimeter and sheet is 1 meter square, then this formula will work. Are you getting it? Okay, now let's move on to the fourth.
2 minutes of lead.
Electric field due to two infinite sheets of charge. Two
Start.
parallel infinite sheets of charge. We are just building it in complexity using the previous building block. So physics course is like constructing a building, multi-story building. Every class you have to have the concepts of the previous class in front of you, and we will use it to build the next concept. So it's very essential that you are regular to class and revise everything. Okay? Okay, can you guys please?
So एक
No,
sir.
sir.
अरे एक सर ने जब से बोले तब से ले रहा हूँ, ठीक है ना?
आज से बैठ जा रहा हूँ.
बंद कर दो तब तक वीडियो.
No, if I close the, we shut the video, then we will have multiple clips.
So it's charge.
Combining will take